All right, here I'm going to show you how you actually use the Q equals MC delta T equation in order to solve for some values. So here's a very straightforward problem to start off with. The question is, how much energy is required to raise 500 grams of iron that is originally at 27 degrees to 37 degrees? And here I tell you that the specific heat capacity of iron is 0.45 joules per gram degree Celsius, or I'm sorry, gram Kelvin. I'm going to tell you why I keep screwing that up here in a second. So it's joules per gram Kelvin or joules per gram degree Celsius. So we're going to be using the Q equals MC delta T equation. So remember, Q is the energy or the heat. M is the mass. C is the specific heat capacity that's given. It's material dependent. Here I told you the specific heat capacity of iron was the 0.45 joules per gram Kelvin. Delta T is the change in temperature, T final minus T initial. Okay, so Q is what we're going to be solving for. Mass, we have the mass of this iron is 500 grams. The specific heat capacity, 0.45 joules per gram Kelvin. And now let's talk about delta T. Delta T is T final minus T initial. For this particular one, we're talking about iron initially at 27, ending at 37. So T final is 37, T initial is 27. And now why do I keep screwing up Kelvin versus Celsius? Let's do it both ways. Let's find the delta T for this particular one in degrees Celsius. So T final is 37 minus T initial is 27. The delta T then is 10 degrees Celsius. Let's figure it out in Kelvin. So let's convert 37 to Kelvin. 37 plus 273.15 is 310.15. 27 plus 273.15 is 300.15. Well, that's also 10 Kelvin. So this is why I keep screwing this up on you. Because honestly, when you're talking about a delta T, it doesn't matter. Because a Kelvin and the Celsius temperature scale are based on the same kinds of units, they have the same kind of gradations. When you're talking about a change in that temperature, it's the same, whether you talk about Celsius or Kelvin. So if you want to keep it in Celsius, that's fine. If you want to convert to Kelvin, that's fine. I'll show you when I do convert, but when you already have the delta T already for you, you don't have to do any of the conversions to Kelvin first. Okay, so we then know our change in temperature is 10 Kelvin. Now we just have to plug things into the equation. So Q is equal to 500. And again, I'm going to do the same thing that I typically do during the gas laws, as long as my units match my units. So energy is going to be popped out in terms of joules. Grams is going to cancel with grams. Kelvin is going to cancel with Kelvin. I don't worry about putting them into the equation. So 500 grams times the specific heat capacity is 0.45 times 10 gives us the energy required to raise that piece of iron from 27 to 37 degrees Celsius as 2,250 joules. Now you need to take a step back and think about this for a second and make sure you have the right sign. The iron is getting hotter. Since the iron is getting hotter, it is gaining energy. Gaining energy should be a positive value, and that's what we got, so that makes sense. So if it took 2,250 joules in order to raise that iron, how much energy was lost by the surroundings? The surroundings lost 2,250 joules. Equal in magnitude, but opposite in sign. So it lost 2,250 joules. So the Q of the surroundings is negative 2,250 joules.